In this video, we will analyze the graph of a quadratic, also known as a parabola. So what we want to be able to do when you have watched this video is recognize the characteristics of parabolas, understand how the graph of a parabola is related to its quadratic function. You want to find the maximum or the minimum value, which is called the vertex, and we want to solve problems involving a quadratic function's maximum or minimum value, and then lastly use technology to find maximums and minimums. So what are the characteristics of a parabola? Well, in general, a parabola is this U shape that you see on this graph, and the U shape may cross the x-axis. Those are called the x-intercepts, these 2 points here. It may cross, actually it will cross only once, the y-intercept, and it will have a low point or a high point that we call the vertex, which is down here in this case. That's a minimum in this particular case. And we have this red dotted line that goes through the vertex that is our axis of symmetry. So one thing that we know about parabolas is that they are symmetric about that line that we call the axis of symmetry. So how do we find each of these particular characteristics? Well, we want to be able to first find the vertex. The vertex is the maximum or the minimum point. So we have what's called the general form of a quadratic that you're probably used to working with. And that is f of x equals ax squared plus bx plus c. And this is useful for us if we want to factor or do other things, but if we put it in the standard form, which is in this box here, we can look at the equation and find our vertex. So if our equation is in the form a times the quantity x minus h squared plus k, our vertex is going to be the ordered pair h, k. Now notice that it does have a minus sign in here, and it does not have a minus sign here. That is because the minus sign is part of the equation. So the first thing that we're going to do is use this standard form of a quadratic to find the vertex and the axis of symmetry. So if we think about how we have shifted graphs in the past, we know, looking at this, that our parent function is an x squared. So we should recognize this as a parabola, and we have shifted it to the right 2 and down 1, which means our vertex is going to be 2, negative 1, and our axis of symmetry has to go through that, and it will be x equals the x coordinate, which in this case is 2. For our second example, you may notice that we have x minus 4 squared. We also have a negative out here. We'll talk about that. And a 3. In this particular case, our vertex is the hk, which is positive 4, positive 3. Our axis of symmetry is x equals 4. And because this has this negative sign here, we know that this particular parabola is going to open down. So if we have a minus sign there, it's going to open down, and the first one here, we did not. We're going to open up. So what if the function is not in this standard form already? Then we have to put it in that form by completing the square. So when we complete the square on the general quadratic, we're going to do the following. So for the first one, I'm just going to keep my f of x on the left, and I am going to move, literally, just kind of move it out of the way, our plus 6. And I know that I am going to have to add something and subtract that same something to keep this equation balanced. And if you recall, we take half of this term, so half of 2 is 1, and we square it, and we get 1. And if I add 1, I must also subtract 1. This part is now a perfect square trinomial. So we have f of x equals x plus 1 squared, and then plus 5. So in this case, our vertex is -1 and +5. It's negative because in order to fit the formula, I need the negative sign in there. So my h is the -1. So it's always going to be kind of opposite of what you think for your x coordinate. Your axis of symmetry should be x equals -1. All right, this next one's just a little bit different because we have a coefficient here. So I am going to start by factoring out, just out of the first two, the 3. And I'm doing that so that I just have the x squared. And I'm going to move my 2 just kind of out of the way like I did before. So you can see at this point, if you distribute that 3 back through, you have exactly what you started with. I am now going to take half of this 2, which is 1, and I will square it, and I get 1. So I'm going to add 1. Now over here, you would think I would subtract 1, but I really, if I distribute that 3, I added 3. So I have to subtract 3. So now I have g of x equals 3. This is x plus 1 quantity squared minus 5. And we still have a -1 and -5 in this case. And our axis of symmetry is x equals -1. So completing the square so that we have it in standard form is one way to find our vertex. Another way to find your vertex is a formula. And the vertex, if we have our function ax squared plus bx plus c, then the vertex is the negative of the b divided by 2 times the a, and then the y value is the function value evaluated at -b over 2a. So here are some examples. Let's find the vertex of 3x squared plus 6x plus 5. So for my x coordinate, I'm going to do -b over 2a, which in this case is -6 over 2 times 3, or -1. So this is the x coordinate of my vertex. And then I'm going to find the function value at -1, 3 times -1 squared, plus 6 times -1 plus 5, 3 minus 6 plus 5, and get 2. So our vertex in this case is x is -1 and y is 2. So this will probably be your preferred method for finding the vertex, but completing the square is useful later when we talk about conic sections. And also, if it's already given in that form, we can recognize what our vertex is. So in this particular case, our vertex would be +4 and 7. We can also use technology It's very similar to using your TI to find a 0. You're going to put your function into y1 and then hit second quit and then go second calc and then scroll down to either a maximum or a minimum, and you're going to know based on the graph if it's a maximum or a minimum. And then it's going to ask you for a left bound, a right bound, and then a guess. So, for example, if you have something that looks like this and you want to find this low point, you would choose min, and then you would put something to the left, something to the right. You would hit your enter when you get your cursor, and then you move it to where you think it is, and then hit enter. No matter how you find the vertex, you can always choose an x value, an equal distance to the left and to the right of your vertex, to get a little bit better picture if you're doing it by hand. Here's an example. If I have x squared minus 7x plus 12, I want to find the vertex. So I'm going to use x equals negative b over 2a. So in this case, 7 over 2 times 1, or 3.5. And then I will find my y value if my x value is 3.5. So 3.5 squared minus 7 times 3.5 plus 12. In this particular case, I get negative 0.25. So here we are, 1, 2, 3, 4. So at 3.5, I'm barely below. And I'm going to choose 3, and I'm going to choose 4. So if I plug a 3 in, that's a half a unit away to the left. I'll get 3 squared minus 7 times 3 plus 12. And I get 0. And similarly with my 4, I also get 0. So in this particular case, that helps me kind of know how wide my parabola is going to be. In this next example, we have f of x equals 3x squared plus 6x plus 5. What I know right now from looking at this is that because the coefficient of my squared term is positive, this is going to open up. If I want to know my nature of my solutions, I can look at the discriminant, which is b squared minus 4 times a times c, and I'll get 36 minus 72, which is less than 0. So this means there are no real intercepts. So how would we graph this if we did not have our calculator? Well, what we would do is find our vertex. I'm going to use negative b over 2a. That's negative 6 over 6, or negative 1. And then I'm going to find the function value at negative 1. So this will give me 3 minus 6 plus 5, which is 2. So here we are at negative 1, positive 2. That's my vertex. And it opens up. And I'd like to know where, for example, it crosses the axis. So if I just choose values, for example, 1 unit away in each direction. Let's see what I get. So I'm going to choose 0. I'm going to say, what is f of 0, which is 1 unit to the right, and what is f of -2, which is 1 unit to the left. So f of 0 is 3 times 0 plus 6 times 0 plus 6. And then we know that it's symmetric, so if I plug in -2, it should also be 6. Let's see. 3 -2 squared would give you 4. 6 times -2, and then plus 6. So 12 minus 12 is 0 plus 6. And so we can see that this is a very skinny parabola. Last but not least, how do we find the x and the y intercepts of a quadratic function? Well, we have a little extra in here, I think. If we have a quadratic function, f of x, and we want to find the y-intercepts and the x-intercepts, we do it the same way we find x and y-intercepts for everything. For find an x-intercept, we let y equal 0, and to find a y-intercept, we let x equal 0. So let's take a look at this example down here. We want to find the x and the y-intercepts. So if I let x equal 0, in other words, f of 0, in this particular case, I get 3 times 0 squared minus 5 times 0 minus 2. So I get 0, -2 for my y-intercept. For my x-intercept, I need to set the function equal to 0. And in this particular case, it does factor. As x minus 2 and 3x plus 1. So our intercepts here, our x-intercepts are going to be x equals 2 and x equals -1/3. So 2, 0 and -1/3, 0. That concludes the video on analyzing quadratic functions.